Welcome to the video lecture series of Grade 10 Chemistry. Today we are going to discuss Chapter 4, Carbon and its Compounds. In this lesson, we are going to study about chemical properties of carbon compounds. Chemical properties means what are the chemical reactions that carbon compounds undergo. So there are four important types of reaction carbon undergoes. The first one is combustion. Second one is oxidation. And third one is addition. And the last one is substitution reaction. So these are the four important chemical reactions of carbon compounds. Combustion, oxidation, addition reaction and substitution reaction. Now we are going to study in detail what are these reactions about. Let us see individually what are these reactions. Now the first one is combustion reaction. So combustion as a word meaning is burning reaction in which carbon undergoes burning or carbon burns in oxygen to give carbon dioxide along with the release of heat and light. So when carbon burns, carbon dioxide is the main product along with the release of heat and light. That's why carbon compounds are mainly used as fuels. Most of the carbon compounds also release a large amount of heat and light on burning. That's why I told already carbon compounds we mainly use as fuels. So carbon C plus O2, the symbol of carbon is C. Okay, when it burns we write O2. So product will be carbon dioxide CO2 plus heat and light. This is another compound of carbon which is called methane. Methane, the formula is CH4. Okay, now when it burns there is hydrogen also present in methane. So this hydrogen will combine with the oxygen and form water. The main product is carbon dioxide. Along with this carbon dioxide we get water also, and then heat and light are the other two products. I mean other two energies released, heat and light. So methane can be used as a fuel. The next reaction is with the ethanol, CH3 CH2OH, or you can write it as C2H5OH. What is its formula? This formula is for ethanol. Ethanol is the second member in the alcohol series. CH3 CH2OH. When it burns in oxygen, the product will be carbon dioxide, then water, and then heat and light. So when you look at these three reactions, what did you infer from this? If carbon alone will give you carbon dioxide. If there is hydrogen is there in any of the carbon compound, you get water as one of the product. Fine. Now, other than this water and carbon dioxide, no products are formed on the combustion reaction. So the main products are carbon dioxide and then water. No other products are formed during the combustion of carbon compounds, and a large amount of heat and light is produced. Okay, so these are the reactions of carbon compounds on combustion. Now we have some one or two points to note along this reaction. We already studied about saturated and unsaturated hydrocarbons. Saturated hydrocarbons usually contain single bond, while unsaturated hydrocarbons contain carbon-carbon double bond or triple bond. So saturated hydrocarbons will generally give a clean flame. So this is saturated carbon compounds. They have only carbon-carbon single bond. So when the single bonded compounds undergo combustion, The color of the flame is clean flame, which means it is blue in color, blue color. While unsaturated hydrocarbons, that is carbon-carbon double bond, alkene, or carbon-carbon triple bond. So this is alkyne. So they are the unsaturated carbon compounds. When they undergo combustion reaction, they will give a yellow flame with lots of black smoke and a sooty deposit. This is because of the incomplete combustion. Because when as unsaturated hydrocarbons undergo combustion, they have to break down this double bond and this triple bond. So accordingly, the reaction will be incomplete, which leads to incomplete combustion, and they produce lots of black smoke and the sooty deposit. Even in the case of saturated hydrocarbons, the supply of air is incomplete, which means the limited, if you are doing the reaction of saturated hydrocarbons with the limited supply of air, it also leads to incomplete combustion and give a sooty flame. So just note that point also. Limiting the supply of air leads to incomplete combustion of saturated hydrocarbons. So even saturated hydrocarbons also can undergo incomplete combustion. Okay, but usually we say saturated hydrocarbons completely burn and give a blue flame. Unsaturated hydrocarbons will give a yellow flame. Okay, now these are the two practical questions usually asking related to this combustion reaction. So the one is if you observe the bottoms of cooking vessels in kitchen, they get blackened. It means that the air holes are blocked. Okay, and then the fuel is getting wasted. So when you are working in the kitchen, or if you are helping your mother, or you can go to kitchen while cooking and check whether the bottom of the cooking vessels getting blackened or not. What is this reason? This is because of the air holes of that burner getting blocked due to dirt. Okay, because we are not cleaning it properly regularly, so the air holes got blocked and the fuel is getting wasted. So that leads to incomplete combustion of the fuel. Okay, that's why the cooking vessels, the bottom portion will be getting blackened. So this is one of the real life application question usually asking. This is a real life application question usually asking related to combustion reaction. Now this is an extra point which you have to note that fuels such as coal and petroleum, they will have some amount of nitrogen and sulfur in them. So when these compounds undergo this combustion reaction, it results in the formation of oxides of sulfur and nitrogen, and they are the major pollutants in the environment. So the important point you just note that carbon compounds, we have that resources like we are getting carbon compounds from coal and petroleum. They will have some amount of nitrogen and sulfur. So during this combustion reaction, they also reacting with the sulfur will react with oxygen as well as nitrogen also reacts with the oxygen and form their corresponding oxides like sulfur dioxide and nitrogen oxides. So they are major pollutants in the environment. So this is about the combustion reaction. The second reaction is oxidation reaction. As you know, what is oxidation reaction? Oxidation reaction is addition of oxygen. You studied in the first lesson. Carbon compounds also can easily oxidized on combustion because it's a reaction with oxygen. But other than this combustion reaction, if you supply some compounds which have oxygen in them, so that we can bring about oxidation in those carbon compounds. For example, alcohols we can easily convert it to carboxylic acids using this oxidation reaction. So alcohol formula CH3 CH2OH. So we should provide some substances having oxygen in them For example, KMnO4, potassium permanganate contains 4 oxygen, or potassium dichromate, K2Cr2O7, potassium dichromate. Okay, both are having enough number of oxygen atoms. Potassium permanganate we use alkaline medium. Potassium dichromate we use acidified medium, acid medium. So these are compounds which we can say that they have some oxygen in them. So they can provide this oxygen to chemical reactions. So some substances are capable of adding oxygen to others. These substances are known as oxidizing agent. So alkaline potassium permanganate or acidified potassium dichromate, they are oxidizing agent because they have oxygen in them. So they give this oxygen to chemical reactions. So they are oxidizing agent. So we can bring about oxidation in alcohols by using this any one of this oxidizing agent. With the presence of heat, alcohols are converted to acid. So ethanol will have two carbon atom. So correspondingly, ethanoic acid is the product, CH3COH. This also will have two carbon. So this is ethanoic acid. So ethanol can be converted to ethanoic acid by oxidation with alkaline potassium permanganate or acidified potassium dichromate. So what is oxidation reaction? Oxidation reaction is generally addition of oxygen. During combustion, oxidation is happening. But other than the combustion, how do we bring about oxidation? If you give any compound which have oxygen in them, you can use those substances as oxidizing agent and bring about oxidation. So alcohol can convert it to ethanoic acid by using oxidation with alkaline KMnO4 or acidified potassium dichromate. Both are having oxygen. They are capable of providing oxygen to other substances. So these substances we say oxidizing agent. So this is oxidation. Now the next reaction is addition reaction. Addition reaction, as the name indicates, adding something to carbon compounds. But one important point you have to note in this addition reaction is that only unsaturated hydrocarbons undergo addition reaction. So addition reaction is carried out only by unsaturated hydrocarbons. What are unsaturated hydrocarbons? They are having carbon-carbon double bond, or they are having carbon-carbon triple bond, which means alkenes or alkynes, or in whichever the compound there is carbon-carbon double bond or triple bond comes, those substances can undergo addition reaction. So generally we can say unsaturated hydrocarbons, they add. Addition means adding. So what are they going to add? They add hydrogen. They need some catalyst for this reaction. So what are catalysts? Catalysts are substances, okay? Catalysts are substances that cause a reaction to occur or reaction to proceed in a faster rate, okay, without undergoing any chemical reaction. So catalyst, they are substances and they cause a reaction to occur at a different rate. Some reaction can be fast, some reaction can be slow. So accordingly, we can use the catalyst. So it only alter the rate of a reaction. It only alter the rate of a reaction without undergoing any permanent change. So catalyst will undergo any reaction, they will slow up or they will fast the reaction accordingly. So in this addition reaction, we use a catalyst. So these are the catalyst, palladium, or we use nickel. So unsaturated hydrocarbons are converted to saturated hydrocarbons. So double bond or triple bond, that will be breaking, and then it is converted to single bonded carbon compounds. So this is the use of that addition reaction. So where do we use this addition reaction? This is used in the hydrogenation of vegetable oils using nickel catalyst. So this reaction is used in the hydrogenation of vegetable oils using nickel catalyst. So the reaction can be represented in this manner: C double bond C. Okay. So this R can be hydrogen or any alkyl group. So this is used in presence of nickel catalyst. Nickel catalyst. Okay. This is the nickel catalyst. What are we going to add? We are going to add hydrogen. This double bond will break and it's converted to single bond. When the double bond is breaking, the valency will be increased. So before we have only two R groups around each carbon, but now we have three valencies around each carbon. Along with this fourth valency satisfied by second carbon. For example, if you write this reaction with the simple compound like ethene, I'll show you with ethene, C double bond C, C double bond C. Okay, this is ethene, CH2, CH2. This compound is ethene or ethylene. You can write in this way also, CH2 double bond CH2. Okay, this reaction we use nickel catalyst. We are going to add hydrogen plus H2. Okay, this bond will break, carbon-carbon bond will break, and it is converted to single bond. That fourth valency is 1, 2, 3. Then this is the fourth valency. Here also all become single bond. Double bond is breaking and it is converted to single bond. So this compound have 6 hydrogen atoms now. Before it has 4 hydrogen atoms because it was an alkene, ENE. Now this is ethane, ANE. So alkene is converted to alkane by addition reaction. Okay. And as I told before, this reaction is used for the hydrogenation of vegetable oils. Vegetable oil will be converted to saturated compounds by using nickel catalyst. Usually vegetable oils will have, this is one important point you have to note, vegetable oils have long unsaturated carbon chains. Okay, so when we add this hydrogen, the unsaturated hydrocarbon chain will break down and form saturated compound. But animal fats, they have saturated carbon chains. Okay, so vegetable oils will have unsaturated carbon chain, but animal fats will have saturated carbon chains. Sorry. Now we have to check which one is more good for our health. Is it animal fat or is it vegetable oil? Animal fats, we said it is contain saturated fatty acids are said to be harmful for health. So we should not be chosen any animal fat for cooking. But on the other hand, oils containing unsaturated fatty acids. So vegetable oils containing unsaturated fatty acids should be chosen for cooking. This is very important to note. Oils in the sense vegetable oils, they containing unsaturated fatty acids and it should be chosen for cooking. So these are the applications of our addition reaction. Addition basically means adding hydrogen to an alkene or alkyne. So generally we say unsaturated hydrocarbons, and so that it is converted to saturated hydrocarbons. So we should use some catalyst. Platinum, palladium or nickel are the catalyst. Okay. Fourth reaction is substitution reaction. Substituting something. We are substituting one atom or a group of atoms with the other atom or group of atoms. That's called substitution reaction. So usually our saturated hydrocarbons, alkanes, they are unreactive. They are unreactive and are inert. Inert means they are not reacting in presence of most reagents. But in presence of sunlight, in presence of sunlight and chlorine, we can add chlorine atom to hydrocarbons. That will be a very fast reaction. The chlorine can replace the hydrogen atoms one by one. So hydrogen atoms will be substituted by chlorine atoms. So it's called a substitution reaction because one type of atom or group of atoms substituted by another group of atoms. So usually a number of products formed with a higher homologue of alkanes. If you use other different homologues of alkane like propane or butane, we get another different types of product. But here we are going to show with the methane. So methane undergoes substitution reaction with the chlorine atom. So CH4 plus Cl2 gives CH3Cl plus HCl. So there are four hydrogen atoms here, CH4. So there are two chlorine atoms. So one hydrogen will be replaced with the one chlorine. So the product is CH3Cl. And second hydrogen will be reacting with the chlorine to form HCl. So this is the reaction CH4, okay, plus Cl2 plus Cl2. Out of these four hydrogen atoms, one will be replacing with the chlorine CH3Cl and the byproduct will be HCl. Now, this reaction is a chain reaction and it will not stop here. That will again react CH3Cl, again can react with the chlorine to form second, out of the three hydrogen, one more hydrogen will be replaced with the chlorine. So we get CH2Cl2 and HCl. Okay, now there are two more hydrogens are left in this reaction. So that hydrogen also we can replace with the chlorine. The product will be CH2Cl2. This is our product in the previous reaction. Now this is acting as a reactant. And out of these two hydrogen, one will be replacing. So we get chlorine. Again, one more chlorine is adding and one hydrogen is replaced. So CHCl3. The last reaction, CHCl3 again come for this reaction. So product will be last hydrogen will be replaced with the fourth chlorine atom and one HCl. So look at these reactions, a variety of products formed. Here only one hydrogen is replaced. Here two hydrogen is replaced. Here third hydrogen is replaced. Here fourth hydrogen is replaced. So in the last reaction, all the four hydrogen atoms are replaced by chlorine atoms. Okay, so last one we call it as carbon tetrachloride and this product is chloroform. This is dichloromethane and this one is monochloromethane or methyl chloride. But in your textbook, you need to study only one reaction. For the time being, I told you, if you wanted to learn, you can learn that, okay? So what is this reaction? This reaction is methane plus chlorine. One reaction you have to study. I just wrote all the reactions to get an understanding on this substitution reaction, okay? CH4 plus Cl2 gives CH3Cl plus HCl. So this is the reaction you have to study very clearly, very thoroughly. So this is happening in presence of light. So these are the four reactions of carbon compounds. So we can write a summary here. The first reaction is combustion. So what is combustion reaction? Burning, right? So product will be carbon compound burning. You will get, for example, methane on burning. We get carbon dioxide plus H2O along with the heat and light. Heat and light are the other products. So what are the points we should note here? Saturated hydrocarbons. What is saturated hydrocarbons? Saturated compounds will give you blue flame, okay, because complete combustion take place. On the other hand, unsaturated hydrocarbons, they do not undergo complete combustion, so they give you a yellow flame with lots of smoke and sooty deposit on the container, I mean on the flame. Now, one real life application we studied, what is that? Bottoms of bottom portion of cooking vessels getting blackened. Why? Air holes, the inlet air holes are blocked. So that what happened then? Incomplete combustion take place. Incomplete combustion take place. So fuel getting wasted. Fuel is getting wasted. On combustion reaction. Okay, and then one more point you can write, large amount of heat and light is produced, that's why this hydrocarbons used as fuels. Okay, fuels. Now the second reaction we studied is oxidation reaction. What is oxidation reaction? Oxidation is actually this combustion is also oxidation, but here we are not providing any direct heat. In oxidation we provide oxidizing agent. What is an oxidizing agent? They have enough number of, they are capable of providing oxygen, capable of giving oxygen. We studied acidified KMnO4, acidified KMnO4, or you can give alkaline, I mean that we have alkaline KMnO4 and acidified potassium dichromate. KMnO4 is alkaline KMnO4 and acidified K2Cr2O7 potassium dichromate. Okay. So ethanol can be converted to ethanoic acid. What is the formula of ethanol? CH3CH2OH. This is ethanol. You can convert this to ethanoic acid, CH3COH, in presence of any of this oxidizing agent. Okay, that is oxidation reaction. So the next reaction we studied is addition reaction. Addition. What is addition reaction? Addition means adding hydrogen in presence of catalyst. In presence of any catalyst like nickel, palladium or platinum. So CH2 double bond CH2 double bond CH2 plus H2 in presence of nickel catalyst, it's converted to CH3 CH3. Okay, so this is addition reaction, and we said vegetable oils are unsaturated, and this should be chosen for cooking, and this is good for health. And animal fat are saturated and should not be used for cooking because it is unhealthy. Now, and this addition reactions is mainly used to convert. What is it used? It is used to convert vegetable oils into vegetable ghee. Now, the last reaction we studied is substitution reaction. What is substitution? Substitution is substitution reaction. What did we study in substitution reaction? Substitution means we are substituting one group of atom, or we are replacing one hydrogen from the alkane to uh, chlorine or bromine or any other atom or group of atoms. For example, in methane, the alkanes are usually inert. They are usually inert. Inert means they are not reactive in usual conditions, but they undergo substitution. We can add chlorine in presence of sunlight. Okay. So, for example, methane can be substituted to chlorine. So we get the product CH3Cl plus HCl. This is happening in presence of sunlight. So these are the four reactions we studied: combustion, oxidation, addition, and the last one is substitution. Thank you for watching the video, children. We'll come with another video on the next class. See you. Bye bye.